Hi, this is Veza, and today we're going to talk about the if, else if, and else statements, which are absolutely necessary to understand to program properly. And it's quite tricky at the beginning, but once you get it, you really get it. So, well, you kind of know me now. I like to use examples. So let's say that I'm in a room, alright? And in that room, you have 3 doors. So you have door number 1, door number 2, and door number 3. Okay? Each door can only have 2 states. The door is either opened or closed. Say I want to get out of the room. So I need to find an open door to get out of the room. Okay. Let's say I'm going to check from the smaller number to the biggest one. So from 1 to 3. If door 1 is open, that I'm going to get out from door 1. Logical. Else means that door 1 is not open because I'm going to check door number 2. Else if door number 2 is not opened, which is the case, I'm gonna check door number 3. So if door number A is closed, else if door number 2 is closed, what is left? The rest of it. Else, check door number 3. Sorry for that. Door number 3 is open. So I'm going to get out through door number 3. Sounds a bit hectic. Sounds like, what's she talking about? Okay, now imagine that the only open door is the door number 2. And again, checking from door number 1 to door number 3. So if door number 1 is open, not the case. So I'm not even entering in what door number 1 can do or cannot do. It doesn't matter, it's closed. Else, if door number 2 is open, okay, it is. So I'm going to do what I said I was going to do. Walk out of the room. Yes, there is a third door, but it doesn't seem logical to you to go back and check the third door to see if it's open. And okay, if it's open, am I going to choose door 2, door 3? No. The first one you found is the one you chose. Okay. Another example. Say, I want a t-shirt that has neither blue nor red in it. Okay. So, if the t-shirt has blue, I don't take it. Else, if the t-shirt has red in it, it's a no. Else, and that else is important because basically that else contains everything that is not blue or red. So, a lot of possibilities. Else, take the t-shirt. You see that basically it's very binary again. In if, else if, else, and that could be like if there are 4 doors, there will be 2 else if. So if door 1, no. Else if door 2 open, no. Else if door 3 open, no. Else door 4 open, yeah. Alright. So as many else if as you want to, but not too many, because in that case you would rather use what we call a switch case. But it's really binary. It's like if you're checking for a letter to be alphabetical, okay? So have, oh no, the letter I. Is I alphabetical? Yes. So if I is alphabetical, what can I check? The case. Is this I uppercase or lowercase? If this I is lowercase, I don't know, what can we do it? Make it disappear, alright? If I is lowercase, and here it's not because, you know, you don't see the dot. So you don't get into that throwing the pen and disappearing. So what's left? What's left is uppercase. But do you really need like to precise it to add else if my letter is uppercase? No, you don't need it, because a letter is either lowercase or uppercase. There are no 1,000 possibilities too. If it's a letter, it's either uppercase or lowercase. It could be brown, writing, whatever, but it could be either lowercase or uppercase. Here it's uppercase, so else. Just an else is enough, because by default, if it's not lowercase, it is uppercase. Else, I know, write with it. So I write with it. So do not use too many else if, for instance. And remember, always remember that when you use else, there is no statements between parentheses, because else means everything else. So there is nothing to state. It's else is not the first one I check, not the first if, not the possible 3 else if that I had before. It's just the whole rest of it. Okay, so I hope that it was good for you. Don't hesitate to pass any feedbacks, and if you need some more explanation, there's no problem. I'm here for that. So this was Faiza, and this was the if, else statements video. See you.